Hi guys, my name is Aram Khachaturian from NeoCraft Games. It's the third video about simulating vehicles in physics. Today we will talk about horsepower. We will learn what does it mean, how calculate, and so on. And beside horsepower, we will learn about watt, RPM, and we'll have real examples. So subscribe to our channel, click like, and let's go. So let's understand what does horsepower mean. Here we have a horse and have a peg gauge, and we see that our horse rises peg gauge 1 meter during 1 second. The mass of peg gauge is 75 kilograms, and uh, acceleration of gravity is 9 and 8 meters to second square. After this, we could define what does horsepower mean. So horsepower is a power to raise a mass of 75 kilograms against the Earth's gravitational force over a distance of 1 meter in 1 second. So let's calculate. So 1 horsepower is equal 75 kilogram times 9 and 8 meter to second square times to 1 meter second. Here 1 horsepower is equal to 735 approximately. So about unit, here we have kilograms times meters to second square is equal to 1 newton, and 1 newton times meter second is equal to 1 watt, I guess. So we could say that 1 horsepower is equal to 735 and 4 watts. I guess we all heard that, for example, this car has 150 kilowatt, which is 150,000 watt, and we from this formula we could convert it to horsepower. So here we have a table of horsepower and watt. We see that the power of 1 horsepower engine is equal to 735 watt. 2 horsepower is equal to 1,470 watt, and the last is 200 horsepower. For example, it's equal to 147 kilowatt approximately. So in the next slides we will observe relations between torque, horsepower, and RPM in the example of Chevrolet Corvette from 1999. So these technical characteristics are from Google. We see that number of cylinders are 8, red line RPM, or in the other word maximum RPM is 6000, horsepower is 345, torque is 350, power is 253 kilowatt. So let's move on. This curve is real example from Chevrolet Corvette. Here we have torque curve and horsepower curve. Torque curve is yellow and horsepower is red. So we see that torque curve peaks at about 4,400 RPM with a torque of 350, and horsepower peaks at 5,600 RPM at 345 horsepower. So also we see that our curves start from 1,000 RPM to 6,000 RPM, because that is an operating range of engine. Any lower and the engine will stall, and any higher and we will damage our engine. So we here see that these two curves cross in 5,242 RPM, and they always cross in this point. And we could calculate horsepower, which is equal to torque times RPM and divided by 5,242. We will check it it's always right in this curve, and for a certain vehicle, and if we get some point of torque, for example 300, we will calculate and see that this formula is right. So let's continue. Here we have the same curves and the same formula where horsepower is equal to torque times RPM and divided 5252. We remember this value. It's the value where these two curves cross, and let's check this formula. We will give a point from torque curve. In this example it's 347, and current RPM is 7670, and let's calculate. Here we see that horsepower is equal 347 times 4670 divided by 5252. It's equal to 308, and we could check this value from this diagram, and we see that it is right. So this formula is always right. We have finished our third lesson. If you like our videos, click like, subscribe to our channel, and have a good day.